All right, guys. Good morning. Good morning. So today, your assignment for today is a quiz on solutions. Okay. And I realized yesterday some people took the quiz and they asked some questions about a few of the questions that I put on here, and I realized that I didn't go over something. Which is, let's see here, this one. There's, I think, 4 questions. So this one here, why does vapor pressure lower as you add non-volatile solute particles? Why does boiling point increase? Why does freezing point lower? And colligative properties of solutions only depend on. So those 4 questions I hadn't gone over. Totally forgot, totally slipped my mind. I forgot to finish off the notes here and go over colligative properties. I did just put in the classwork assignment here, I did put the Google Slides, and I updated them with these notes here. It does not, however, answer all of those questions. It just tells you about colligative properties. So really briefly, colligative properties, they are properties that only depend on the number of particles in solution. Okay, so it doesn't matter what type of particle there are or the size of them or how they interact. It just matters how many particles in solution. So the number of particles is the only thing that matters. All right, and the number of particles affects 3 different things. It affects the vapor pressure, the freezing point, and the boiling point. Okay, it lowers the vapor pressure, it lowers the freezing point, and it increases the boiling point. Okay, so the more solute particles you have in solvent, the lower the vapor pressure, the lower the freezing point, and the higher the boiling point. Okay, the reason for that, for vapor pressure, the particles get in the way on the surface. So the solute particles, there's more solute particles on the surface, which don't allow as many solvent particles to evaporate. So they get in the way. All right, and vapor pressure is the pressure above a liquid caused by the evaporation of that liquid. So if the solute particles are there, they don't allow as much of the solvent to evaporate. Okay, and they lower the vapor pressure. And this kind of goes hand in hand with boiling point. If the vapor pressure is lower, then that means the boiling point is going to be higher. Okay, because boiling point is when vapor pressure equals atmospheric pressure. So if you're lowering vapor pressure, that means you need to get to a higher temperature to increase the vapor pressure. So they kind of go hand in hand. Okay, so really the lower vapor pressure causes a higher boiling point. Okay, and the vapor pressure lowering is caused by the disruption of the solute particles at the surface of the solvent. Okay. For freezing point, freezing point lowers. Okay, and the reason for that is because the particles interfere with the formation of the intermolecular forces between solvent particles. So solvent particles, in order to freeze, they need to form intermolecular forces to make a solid. Okay, those solute particles interfere with those intermolecular forces and don't allow the intermolecular forces to be made. Okay, so hopefully that will help you answer those questions. Again, I think I'm gonna give you guys extra credit for those because it's kind of slipped my mind. And those of you who did take the quiz already, I think 3 of you, or 1 or 2 of you in this class, and 1 or 2 of you in period 2 took the quiz already. It's kind of unfair that I didn't really go over that. Okay, so I'm just gonna give it to you guys as extra credit. Okay, so that's all you have today is the quiz. if anyone has any questions about